Relative extrema,
shoot.
increasing, decreasing, and constant. So relative extrema is the plural of extremum, which is just a fancy word for maximums and minimums.
Right, extrema just means where you have a peak or a valley on your y coordinates.
Right.
So.
And we are looking at what's called relative or local. Global is not what we want. Isn't that all of?
That's the chief daddy big and
But we don't want
okay, all right.
No, we want local.
Local it is.
Relative and local, because a relative or a local maximum is all the places where we switch from increasing to decreasing, and a relative or local minimum is where we switch from decreasing to increasing.
That's right, peaks and valleys.
A graph is increasing when it is rising from left to
but
right.
I have one you can borrow. Okay.
Decreasing when it is falling from left to right, and constant when it's not going up or down from left to right. So we read graphs from left to right just like you read letters, right?
In English.
In English, yes. Specifically in English, we read from left to right. So if I start over here and I start going this way, am I going up or down?
You're going up.
Okay, and I go up the whole time?
It looks that way.
So this is increasing. It's an increasing function, and it's actually, we again use interval notation for this. It's increasing the whole time.
What x coordinates does it increase?
Right, we only care about the x coordinates when we talk about this. Here, if I start here, I'm going down
Falling
the whole time.
Which means you're decreasing.
This one, what am I doing?
Pretty much you're constant.
Yeah, because if I go from left to right, I'm not going up or down.
Not going up or down at all.
The whole time. And this last one has all three.
Oh.
So from left to right.
Okay, here we go. Left to right. From negative infinity to... Is that a negative 2?
I think it is. It is kind of tiny on there.
You're decreasing. From negative infinity to negative 2. Now,
we have kind of a disagreement.
We have a professional disagreement with exactly how you should notate this. So because of that, you can notate
either way.
Either way.
And it's the math community...
in general,
realizes that both of these things are true.
Right.
You can either put it with parentheses.
Why did you put yours first?
Or brackets, because mine's better. Mine's more right. Because you could say that it's decreasing all the way to negative 2, and you could include that because we don't have a hole there, and that would be a bracket. Or you could just use parentheses the entire time you're doing increasing, decreasing, or constant, which is what I like to do. Because are we really decreasing at a point where they switch?
Yes,
No.
all the way to that point of negative 2, and then you change. Ludicrous, her thoughts.
We are constant from negative 2 to positive 2, and again, you could do that with parentheses.
Why do you put parentheses first? What about my way first? I'm going to take the writer from you.
After this problem, be my guest. And then from 2 to positive infinity, we switch to increasing. Ugh. I just want them to be consistent. Okay? Do it one way or the other, but don't combine them.
Yeah, combining is bad. Be consistent in your beliefs.
Now, if you ever did have a situation where there was an open circle here, you would have to put parentheses.
Right, yeah.
Because it's not equal to there.
The only reason that there's disagreement on this is because we're actually kind of at a corner point.
Right, and so it's the question of,
so we're still defined at that point.
Right,
okay?
But everyone...
has their own opinions on that one. But if you have a hole or an asymptote or a situation where there's a 0 in the denominator, those cannot be included. They just cannot be included at all.
Right. So we already talked about this paragraph. Relative extrema refer to the extreme points of our graph, known as relative maximums and relative minimums, and how it switches. So let's graph this function, and we're going to find all the relative extrema, also known as local, and we'll also go ahead and identify the intervals on which the function is increasing, decreasing, or constant. Those two things kind of go hand in hand. If we're asked increasing, decreasing, or constant, but not asked to find the maxes and mins, we're still going to end up finding them to figure out where the point is that they switch.
So, is that a cubed?
Yes. I happen to know this will have a max and a min. And it has part of the time increasing, part of the time decreasing. The only time you get constant functions when you're plugging in actual functions is if you've got really
piecewise.
weird absolute value or some kind of piecewise situation. So here's what it should look something like this. So we need to find those points. Is that good enough?
I feel like that's probably appropriate.
Because, and the only reason I'm even sketching it is because we need to find this point, which it's not really 0, 1, even though it kind of looks like that on mine right here. But we need to figure out what this is. That's our max. And on your graph, you go to, or on your calculator, you go second trace, maximum. You got to do a lower bound or a left bound and an upper bound or a right bound, and then guess.
And if you have Inspire, you go to Menu, Analyze, and then you pick it.
Right, so what's our max?
Our max is going to be 1.1. And I'm sorry, the x-coordinate is negative 0.22. My mistake.
So wait, what's the point?
The point is negative 0.22, 1.1.
Okay, and then our minimum?
Efforting that. So, still working and processing, and gosh, then of course it stacked the answers one on top of the other. So 1.5 and negative 1.6. Now you could have a slightly different number on these depending on how far out your decimals go.
Right.
But it shouldn't be too different.
We actually prefer 3, but if
3
your
is what we
calculator
prefer.
automatically gives you 1 or 2, then we can deal with that. Once we have our maxes and our mins, now we're looking for
Increasing, decreasing
and
behavior.
decreasing.
And
So we're starting off increasing until we get to here. Now what's
Right.
important is we care only about the x value.
yes.
We're-
What values of x is the graph increasing?
So we're going from negative infinity to negative 0.22. And then we actually start increasing again from here up. So from 1.5 to infinity. I could use brackets on these. I just forgot.
You can't use bracket with infinity, but you could use bracket on the negative 0.22 and the 1.5.
Right. And so in between here now, this is decreasing. So between negative 0.22 and 1.5, we are decreasing.
And again, you can use brackets here. So you do have a little bit of freedom in noting on this, mostly because we're defined at everything,
Right.
which is why we would have the ability to do that should you choose.
If you want to do
if
brackets,
if
do
want to.
brackets.
That's right.